Over the last 3 episodes, we built the individual pieces: embeddings, vector databases, and chunking. In this episode, we connect them all and build a complete RAG pipeline. A user asks a question. We retrieve the most relevant chunks from our vector store. We inject those chunks into a prompt, and the language model generates an answer that is grounded in our actual document. Every RAG system has 3 stages. First is indexing. You chunk your documents, generate embeddings, and store everything in a vector database. This happens once offline. Second is retrieval. When a user asks a question, you embed it and fetch the top matching chunks from the vector store. Third is generation. You inject those chunks into a prompt and send it to a language model. The model reads the provided context and produces an answer grounded in your documents rather than its training data. We start by loading the Chroma vector store we built in episode 3. We point it at the same persist directory and pass the same embedding model. Then we call as retriever and set k to 4. This means every query will return the 4 most relevant chunks from our database. K is a tunable parameter. Higher values give the language model more context, but also increase the prompt size and cost. The prompt template is the heart of the generation stage. We tell the model it is a helpful assistant and instruct it to answer using only the provided context. The phrase, "if the answer is not in the context, say you do not know," is critical. Without it, the model will fall back to its training data and hallucinate an answer that sounds confident but is not grounded in your documents. The template has 2 placeholders. Context will be filled with the retrieved chunks. Question will be filled with the user query. We set up the language model using GPT-4.0 Mini with temperature 0. Temperature 0 means the model will always produce the most likely answer rather than a creative or varied one. For question answering grounded in documents, deterministic output is almost always what you want. We also write a small helper function that takes a list of document chunks and joins their text content into one string with blank lines between each chunk. Now we connect everything into a LangChain chain. The context key runs the user question through the retriever to fetch chunks, then pipes those chunks through our format docs function to produce a single string. The question key passes the user input straight through unchanged. Both feed into the prompt template, which then feeds into the language model, which feeds into a string output parser. Calling invoke on the chain triggers the entire pipeline in one line. Here is the same pipeline written out step by step without the chain syntax, so you can see exactly what is happening at each stage. We retrieve the top matching documents, format them into a single context string, fill the prompt template, call the language model, and return the response text. Notice the second question: who wrote this document? The model correctly responds that it does not know based on the provided context, because that information is not in the retrieved chunks. When your RAG system gives wrong answers, there are 5 places to look. First, check that the right chunks are actually being retrieved before blaming the language model. Second, if the model is ignoring your context and making things up, make the instructions stronger in your prompt. Third, if responses are being cut off, your context is overflowing the context window. Reduce K or shrink your chunk size. Fourth, add citation instructions to your prompt so answers reference their source. And fifth, if speed is an issue, reduce K and cache your embeddings. You now have a fully working RAG system. Documents chunked and indexed, a retriever pulling the right context, a prompt that keeps the model grounded, and a language model generating accurate answers. In the next episode, we go deeper into prompt engineering, specifically for RAG. How to write system prompts that reduce hallucinations and improve answer quality. If you are finding this series useful, please subscribe. It keeps the series going. See you in the next one.